Hi friends, welcome back to another video in the Statistics 101 series. Today we're diving into something called the normal distribution, and it is one of the basic building blocks in stats theory. So let's break it down. A normal distribution is just the way data is shaped when most values are hanging out near the middle. So it looks something like this. A nice symmetrical hill or bell curve shaped. But why is it shaped like this? It's because in many situations, for example, height, weight, or even test scores, most people score around the average, which is what you would expect. And the average in a normal distribution curve is down right in the middle. This is something that you ought to remember. The further you go from the average, the fewer people you find. For example, it's pretty common for someone to be 165 centimeters tall. But it is less common to find someone who's 140 centimeters tall, or say 195 centimeters tall. These are called outliers or extreme values. That's why the curve is tall in the middle and tapers off on both sides, because the middle values are the most frequent and the extreme values are rare. Some key features of the normal distribution curve is that it is symmetrical, meaning the left side and the right side are mirror images. So for things like height, the number of people slightly shorter than average is about the same as those slightly taller than average. For example, so it mirrors on both sides. I'll explain more on the key features of the curve in my next video, so stay tuned. So another key feature is that because it is symmetrical and because it is shaped like this, we know that in a normal distribution, the mean, median, and mode are all the same number, right in the center of the curve. So what that means is that basically, right in the middle, we know that mean is equal to median and is equal to mode. So these three are the same number in a normal distribution curve. But of course, what if the distribution is not normal? That can happen when the data is lopsided, and we call that as skewed data. As a result, we have something called positively skewed distribution or right skewed distribution. This happens when there is a long tail on the right, and we call that right skewed, as you can see here. This means that the mean or the average is being pulled to the right, away from the median and the mode. Therefore, on this curve, we know that the mean or the average would be here, while the median should be around here. And the mode, which is the most frequent value, should be on the part where the curve is the highest. So we see that in a positively skewed or right skewed distribution curve, the mean is always higher than the median. A real life example: income. Most people earn around the middle, but a few super rich people pull the average way, way, way up and earn way more than the average person. That's why, for income specifically, it's usually the case that the average income is higher than the median income. Another possible scenario is the negatively skewed or the left skewed distribution. If the tail is on the left side, then we call that left skewed. Here, the mean gets pulled down and the median is higher. So from this curve here, we can see that the mean is somewhere around here, while the median is higher than the mean, and the mode remains on the highest point of the curve. Therefore, we know that the mean is always lower than the median in a negatively skewed distribution curve. An example: imagine you have an easy quiz that most people ace. Almost everyone scores above 90, but one student was absent and got a 0. That 1 0 pulls the mean down even though most students did great. So the quiz score data becomes left skewed. So the key takeaway is that usually when we talk about a normal distribution, we mean that the data is nice and tidy, meaning no extreme outliers, aka crazy numbers, mess things up. And so it makes it easier for us to work with. That's why when we get a problem to solve, we want the data to have a normal distribution. But if it doesn't, typically we still assume that it's normal, but we just need to add in a few extra steps to make that assumption work. That's what usually happens when you're tackling a statistical theory question, for example. In the next video, I'll show you how we use this distribution curve for something called the z-score or z-value, and how it helps us compare values that come from different datasets or distributions. That's all for this video. Hope you liked it. Subscribe. And this is Easy Econ. I'll see you in the next video. Bye!